Welcome to the Wireshark Overview lecture. In this lecture, we'll introduce Wireshark, one of the most powerful tools in a cybersecurity analyst's toolkit. Whether you're detecting threats, investigating incidents, Wireshark is one of the most respected industry-grade tools that can help you exactly understand what's going on, packet by packet. And now, while it may seem a bit overwhelming at first, but we're going to go step by step, one small step at a time, and after a couple of lectures, you would have become an expert in Wireshark, and you will be able to effectively use it to conduct forensic investigations. So what's Wireshark? It's a free open source network packet analyzer. It captures and displays packets. Originally, it was called Ethereal and it's written in C, C++, and it works across Windows, Mac, and Linux. So why use Wireshark? Well, Wireshark is used to investigate malware communication, for troubleshooting slow network performance. So for example, if your network is experiencing very poor performance, you can use Wireshark to understand what's going on. It's used for detecting port scans. It is used to investigate suspicious logins and so many different things. It's a very powerful tool. So let me just first walk you through the UI of Wireshark and how we are going to use it. So going to our Kali Linux VM, if you go here, so if you go to sniffing and spoofing, you're going to see a bunch of tools and there's Wireshark. You can start it here. And this is sort of like the main landing page or the main display page. So here are the different network interfaces on which you can configure Wireshark to listen to. There's the Ethernet 0, which is the interface between the Kali Linux VM and your host laptop or computer. We have the Docker 0 interface, which we have already discussed is the interface between Kali Linux VM and the Docker container running Nginx container. And then we have loopback and so many others. Now a quick overview of sort of like the main structure of how the UI is basically laid out. So here is where you start the packet capture. So for example, if I have picked Ethernet 0 or Docker 0, I can start listening from here. Okay, and this is for stopping it. And this is for restarting it. Now this one is a very useful button. If you feel confused, just remember this option. Okay, if you just click it, it's going to show you three different options: input, output, and options. And this is where you can basically configure sort of like all of the key things in one window. So first of all is the input. Input basically means which interface do you want to listen to. Do you want to listen to Ethernet 0? Do you want to listen to Docker 0? Any loopback, bridge interfaces? We even have wireless interfaces. So this is where you can easily configure which interface do you want Wireshark to listen to. Okay. And this is the output. So basically you have a couple of options here. So normally if you run Wireshark normally, you don't want to save it in a file. That's also fine. You don't need to specify a file here. But if you want to use a file, so for example, often we want to capture some data and then write it to a file so that we can also access it later on, run analysis later on. So you can specify a file here. Now there are two formats on how you want the output file to be. We have the pcap-ng and the pcap. Let me just quickly walk you through the key differences between these two packet formats. So as we were discussing, there are two key formats. The first one is PCAP. This is sort of like the bit older and classical format. We also have PCAP-ng, which is a bit modern and it has a few more flexibilities. So PCAP format, the legacy one, was introduced in 1990s. This one is a bit more recent. Packet metadata basically means what are the additional details about each capture packet. So in PCAP, it's limited, and with PCAP-ng, it's a bit more rich and extensible. For interface info, if you want to capture files in PCAP format, you can only capture traffic from one interface. But if you want to sort of combine traffic from multiple interfaces in one file, then pcap-ng allows you to do that. Moreover, comments are not supported in PCAP. pcap-ng supports comments, decryption keys, name resolutions, operating system, and app info are also not supported here. They're all supported here. Similarly, sometimes your log files or packet capture files can become huge. So this one doesn't provide an option to compress them. This one basically supports gzip. So it's not a built-in feature, but it works well with gzip, and you can basically compress huge amounts of files into smaller files. Having highlighted the differences between pcap and pcap-ng, I would still say for most use cases, pcap is still good enough. But of course, you have the added flexibility. If you want to use some advanced level options, then you can always use pcap-ng. Going back to the demo. So we already discussed inputs, which is the interface where you want to listen. We discussed the output. You can save a file and then you can specify which format do you want to use. And then you also have additional options. So for example, sometimes you don't want everything in one huge file, right? So you can specify options like, for example, after you have captured 100,000 packets, create a new file. So after the first 100,000 packets, a new file will be created. After the next 100,000 packets, a new file would be created. Okay. But you can also specify, for example, after this many kilobytes have been captured or this much megabytes have been captured, create a new file. This just makes things a bit more manageable. You can also specify in terms of time, when do you want to start capturing to a new file. So for example, if you specify 60, it means that after every 1 minute, create a new file. So the first 1 minute will be one file, traffic in the second minute will be a second file, traffic in after the third minute will be a separate file. Then you can also specify the date convention, like do you want the year, month, day, hour, minute, second, or some other format. Usually I would say most of the default options are good enough, so we're going to go with that. Now going to options, you also have some additional options. So for example, you can automatically configure packet capture to stop after it has captured X number of packets or X number of files have been created. Or for example, you have captured X kilobytes or X megabytes or X gigabytes of data. So this is sort of like all about managing. You can also specify temporary files. So what happens is that if you specify a permanent file here, then Wireshark is going to write everything to this file. However, if you don't specify and you're saying that I just want to see the traffic in the UI, that's it, then it's going to use temporary files to write that data. However, remember, temporary files are temporary and they can be deleted at any time by the operating system. Okay, now let's see some traffic in action. Let's see Wireshark in actual action. So before doing that, what you want to do is that we want to launch the lab. So once again, we are going to desktop labs folder and then sudo /mainscript.sh, and we have added the Wireshark introduction lab. Now please remember, for Wireshark we may introduce more labs as well. So in this one, it's currently option number 5, and as always I would like to mention this may change in the future. The order may be changed because if we introduce new labs, then this numbering would change. But just bear in mind the name and just check the number here. It's 5 for now, so let's do that. Okay, so now the Wireshark intro lab is ready to use. So as always, this is our Kali Linux VM. And then within it, we have the terminal here and we have the Nginx container running here with the IP address 172.17.0.2. And we'll be sending traffic from Kali Linux VM to the Nginx container over the Docker 0 interface as always. However, now we'll configure Wireshark to listen to the Docker 0 interface. So this means that Wireshark is going to capture all the packets that are going to or from the Docker 0 interface. So every packet going across Docker 0 interface will be captured by Wireshark. Okay, coming back to the lab. Now let's configure Wireshark to listen to the traffic on Docker 0 interface. Okay, so let me just expand the window. I always like to use this option, which basically gives you all the different options in one window. So for input, we want to capture on the Docker 0 interface. For output, we don't care about a permanent saving file. So we'll just view the output in the UI. And basically, if you can just simply start it. Okay. And as always, you can stop it, restart it, or change the options from here. But now we are not seeing any traffic because there isn't any traffic going from Kali Linux VM to the Nginx container. However, this is a controlled lab environment, so you're not seeing a huge number of packets. But usually if you start Wireshark on any network interface, you're going to see hundreds upon hundreds of packets. And in the later lectures, we'll discuss how you can be very specific on what type of traffic you want to capture and then what type of traffic do you want to display. So there are lots of different options. However, to keep things simple and to make the concept crystal clear, we are using the Docker 0 interface, which for now doesn't have much traffic. So let's change that. Let's send some traffic from Kali Linux VM to the Nginx container. Let me clear the screen. So let's send two different type of packets. So we can do, for example, nmap, and then let's scan port, for example, 80 on the Nginx container. That's one traffic that we sent. And as you can already see here, results are there. However, let's send one more packet. Let's do a ping, okay? 172.17.0.2, and I'm going to quickly close it because it's going to generate huge number of packets. Okay, so now coming back to the Wireshark window. By the way, a convenient option is this zoom in and zoom out option. You can zoom in and zoom out as you want. And then there are other options as well. So for example, you can remove or add this main toolbar, this capture toolbar, packet window. You can just go here. If you click here, it's going to remove the main toolbar. Similarly, you can remove the filter toolbar, which was here, this one. And then you can also obviously remove packet lists or add packet details, packet bytes. You can even change the display time format. So for example, right now it's showing that since the start of the traffic capture, how many seconds have passed. Okay. But you can obviously change this as well. So for example, if you go here and you can say, no, I want the timestamps in, for example, year, month, day, hour, minute, second, then this is going to change here as well. So it's very flexible. However, I've always felt the default settings are actually good enough. So we want to see the time starting from the first packet capture onwards, so that it makes it very easy for a temporal understanding. And then there are other options as well. So for example, Wireshark uses different colors. For example, light yellow for R packets, green for TCP, and then for reset, it's using red and then pink color. You can always change those colors if you want. So for example, you can go coloring rules and then you can change whatever you want. It's a very flexible tool. Okay, let me zoom in just a little bit. So coming back to what we were discussing previously, let's ignore the R packet for now. Our first traffic that we sent was TCP, right? We did a port scan of port 80 going from 172.17.0.1 to 172.17.0.2, Kali Linux VM to Nginx container. And as you can already see, I mean, TCP dump was pretty useful, but this is so cool. You can see all of the traffic in this window. And please don't get overwhelmed at all. We're going to cover each and everything and make the concepts very easy for you to understand. And by the time we complete all the lectures and labs of Wireshark, everything will be even clearer and you will be an expert at using Wireshark. Okay, so one step at a time. This is the original nmap scan request, which went from Kali Linux VM to Nginx container. The protocol used was TCP. And as you can see here, it's going from port this to this. And then there was a reply packet as well from Nginx container to Kali VM responding to this sort of like scan. Okay, and this basically tells the source that this port is actually open. Now, one very cool thing about Wireshark is that it gives you all of these headers also. Okay, I'm just going to show you the headers once again so that you understand exactly what's going on. And we are discussing this packet, okay? The TCP nmap scan packet going from Kali Linux VM to Nginx container. So if you recall, we had already discussed that you have a sender application or source and you have a destination. Now this packet is going from 172.17.0.1 and it is going to, so this is Nginx and this is, okay, now one step at a time. Now, if you recall, the first header that we discussed was the transport header. And the two fields it contained was the source port and the destination port. Okay. So similarly for this packet, if you expand the transmission control protocol header, the TCP header, you can see source port and destination port. So in this case, what's the source port of Kali Linux VM? So as you can see, the source port is 42405. 42405 or 42405. And what's the destination port? Destination port is 80. So we are talking about port 80 here, or basically destination port 80. So this is the TCP header that you are actually looking at. Now I hope this makes things absolutely crystal clear. So that's something very cool. Let's expand the next header, which is the internet header. Can you guess what would be the IP addresses? Well, yes, source IP is 172.17.0.1. So source IP would not be this one. It would be 172.17.0.1. And the destination IP would be, as shown here, 172.17.0.2. So this is the IP header that you're seeing here, this one, okay, Internet Protocol header. Similarly, the third header was Ethernet header for the same packet, okay, which is this one. And here we specified the source MAC address and the destination MAC address. And here you can see the source MAC address, which would be the source MAC address of Kali Linux VM and the destination MAC address. Okay, so that's awesome. Okay, perfect. So moving on to the ping traffic, in which we sent an ICMP request, a ping from Kali Linux VM to the Nginx container. Once again, you see all of these headers. So we have the source IP, we have the destination IP, and we also have the protocol, which is ICMP protocol. And if you expand here, you're going to see all of the different options once again. Now, please notice in the TCP packet, you are also seeing the TCP header. Okay, but in ICMP, it doesn't have a transport header because it is sort of like an IP layer protocol. So that's why you're not seeing that header. But you're seeing the basically Ethernet header or the link layer header, internet header, once again source, destination IP, and you're seeing the ICMP protocol. So if you recall, we discussed that it has a ping request and then a ping reply. So for example, this one would be the ping request and this packet would be the ping reply. So as you can see, already Wireshark is offering you so many different options. It's such a powerful tool to basically analyze network traffic. And moreover, the nice thing about Wireshark is that it offers a visual GUI, which makes things really easy to analyze and understand. So that concludes our lecture for the overview of Wireshark. We discussed what Wireshark is, why it's used, the UI, different options. In the next lecture, we're going to discuss the packet capture filters and the display filters. Very important topics.